assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this question, we are doing a calorimetry problem. We want to know the mass of ice required to change the temperature of a beverage by 25 degrees Celsius. So remember, when you're doing calorimetry, there are a few things that we need to keep in mind. Q equals mc delta T, where Q is your heat either gained or lost, M is your mass, C is your specific heat, and the delta T is the change in temperature. When you're dealing with two different substances that are changing temperatures, you are also going to be using Q lost equals negative Q gained. It doesn't really matter which side of the equation here that you make negative. Remember, one side is going to gain energy. That's going to be taking in, it's going to be positive. The other side is losing the energy, so it's going to be negative. So in order to get them to be equal, you've got to change one of the signs for either side. All right, so in this problem, we are dealing with water as a solid changing into water as a liquid. The reason I'm starting with this is we need to calculate the delta H of formation for that reaction. Remember, that's the sum of our products minus the sum of our reactants. They gave us the value for the solid water. You had to look up the value for the liquid water in the tables. So our delta H of formation is going to equal a negative 285.83 kilojoules, which is the value for the liquid. And you're going to subtract from that a negative 291.8 kilojoules, which is the value from the solid, right? Products minus reactants. This gives us 5.97. With sig figs, you're going to round that to 6.0 kilojoules for the amount of energy that you have to put into this system in order to melt that ice. We're also going to calculate the delta T. They told us that this started at 25 degrees Celsius and ended at 0. So remember, this is T final minus T initial. So 0 minus 25 is a negative 25 Celsius. That is my delta T. Now, when you are doing this, we have Q lost equals negative Q gained, but the Q lost is not going to be calculated by doing MC delta T because this is a change of state. Whenever you change state, you have to take your number of moles times your delta H of, in this case, fusion. So we calculated what that value is. That's why they gave us the numbers to begin with. So here we have some number of moles times 6,000 joules. I need to convert my 6 kilojoules into joules, is going to equal the negative. I'm going to make this side negative, and you'll see why in a second. The mass of our beverage. They gave it to us in milliliters, but remember, they also told us that the density was 1 gram per milliliter. So milliliters here equal grams, so I just substituted that. Times 4.18 joules per gram degree C times our delta T of negative 25. All right, In this case, we have when we do this math, we just need 355 times 418 times 25. The negative signs are going to cancel each other out. And we're calculating moles. So moles here are going to equal 6.18. And this is really moles of our ice or solid water. So I'm going to just multiply that by its molar mass. That'll get me into grams. This is going to round to 110 grams of ice. If we go back, and I didn't mark it here, this only had 2 sig figs, so this 0 was significant, but the others were not. And if we carry that through the calculation, we are going to end up with 110 grams of ice.